You haven't said a word. Your face is calm. Your voice is steady. You're sitting completely still, but your dog has already moved across the room and is pressing its body against your leg. Something shifted in you, and your dog felt it before you did. This isn't loyalty. It isn't coincidence. And it isn't something trainers taught them. It's biology. And what science has discovered about exactly how it works is more precise than most people are ready to hear. Start with the nose. A dog's sense of smell is estimated to be between 10,000 and 100,000 times more sensitive than a human's. Where we have roughly 5 to 6 million olfactory receptors, a dog has approximately 300 million. That number is almost impossible to visualize. So think of it this way. If your sense of smell were a small flashlight, a dog's would be a stadium floodlight. Same direction, entirely different power. And this hardware isn't just for tracking prey or finding food. For thousands of years, evolution wasn't just changing dogs. It was quietly teaching them to read one species better than any other, humans. Here's where it gets precise. When you experience any emotion, your body changes its chemistry. Stress causes cortisol to spike. Fear releases adrenaline. Happiness triggers oxytocin. These hormonal shifts don't stay inside you. They leak out. Through your sweat. Through your breath. Through the air immediately around your body. You cannot smell these changes. Another human cannot smell them either. But a dog can. In 2022, a study published in PLOS ONE tested this directly. Researchers collected breath and sweat samples from humans in both relaxed and stressed states, then presented them to dogs with no visual cues, no body language, no sound, just the scent. The dogs identified the stressed samples with an accuracy of 93.75%. On the surface, that sounds almost impossible. But the evidence kept pointing in the same direction. And then scientists found something even stranger. Detection, though, is only the first part. A 2024 study from the University of Bristol went further. They wanted to know, when a dog smells stress, what actually happens to the dog. The results forced researchers to rethink what dogs were actually sensing. Dogs exposed to the odor of stressed humans began making more pessimistic choices in behavioral tasks. Their decision-making shifted. Their mood changed. They didn't just detect the stress. They absorbed it. Scientists call this emotional contagion, the same mechanism that makes humans feel uneasy in a room full of tense people or laugh more easily when surrounded by laughter. The emotional state of one individual transfers, chemically and not consciously, to another. In dogs, this transfer is uniquely calibrated to humans. They didn't evolve it around wolves or deer or any other species. They evolved it around us. But smell isn't the only channel. And this is where everything changed. In 2018, a study published in the journal Learning and Behavior confirmed something dog owners had long suspected. Dogs can distinguish between happy and angry human faces. But it's how they do it that reveals exactly how carefully they've learned to read us. When presented with human faces, dogs consistently showed a preference for looking at the left side. The left side of the human face is controlled by the right hemisphere of the brain, the hemisphere most associated with emotional processing and expression. It's the more emotionally revealing side. They're not reading your whole face. They're reading the part that gives the most away. Researchers at the University of Lincoln then added something that changed the picture entirely. Their work showed that dogs don't process emotional signals in isolation. When they hear a happy voice, they look toward a happy face. When they hear a distressed voice, they orient toward a distressed face. They integrate sound and sight the same way humans assemble multisensory, emotional information. This wasn't simple pattern recognition anymore. It was something far more sophisticated. It was emotional comprehension, reading multiple inputs simultaneously, assembling a complete picture of what the person in front of them is actually feeling. But that wasn't the biggest surprise. Your dog's cortisol levels mirror yours. Studies have shown that when owners experience chronic stress over weeks, their dog's cortisol levels rise in parallel, not in response to a single moment. Gradually, persistently, the dog's stress hormones track the owner's stress hormones across time. They don't just read your emotions in the moment, they carry them. A dog living with a chronically anxious owner becomes, on a hormonal level, a chronically anxious dog. The emotional state of the human becomes the biological state of the animal, not through behavior, not through training, but through a synchronization that happens without either of them choosing it. And this is where the story changes what most people think they understand. We tend to assume dogs are reactive. We feel something, they respond. We're distressed, they come closer. We're happy, they get excited. But the research suggests the sequence is entirely different. They don't respond to your emotion. They detect the chemistry that precedes your emotion, and they respond to that. Which means that in some moments, your dog knows what you're feeling before the part of your brain responsible for self-awareness has caught up. Humans and dogs have lived alongside each other for somewhere between 15,000 and 30,000 years. That is a long time to develop a shared language. But we built the verbal part, the commands, the training, the words they learned to recognize. They built the emotional part. And what they built, tuned to our chemistry, calibrated to our faces, synchronized to our hormones across decades of shared life, is more sophisticated than anything we deliberately designed. You haven't said a word. Your face is calm. Your voice is steady. Long before your mind could explain what you were feeling, your dog had already sensed it.